electronics enthusiasts! Welcome back to the next episode of Kool Electronics Guy, where the electronics are cool and the guy, you be the judge. Let's jump right into our beer of the day today. I don't know if you can hear in the background, my cameraman's playing video games, if you hear that back there in our studio. But anyways, now that summer's here, I've been drinking a lot more sour style beers. I tend to drink those more in the summer. I save those heavier stouts and porters for the cooler months. I just like them better in the fall and the winter for some reason. That being said, today's beer of the day is a raspberry sour ale called Minky Boodle. It's brewed by Thin Man Brewery in Buffalo, New York. That's like, I don't know, about 3 hours away from where I am right now. This delicious summer beer weighs in at 7% alcohol by volume. And it's in the higher range of alcohol for this type of beer. Sours really aren't very high in alcohol content. But I've noticed lately that more and more sours are being made from higher alcohol with higher alcohol contents, which is great for me because I like the higher alcohol beers. But if you like raspberries, you're gonna love this beer. It's a nice deep red color when you pour it. Very smooth, with a hint of creaminess. It carries wonderful tones of raspberry goodness. There's a nice tartness that carries on from start to finish, which, it's a sour, so you're kind of looking for that. It's really, a really wonderful sour to try. Beer Advocate scores it a 92 with an outstanding rating. And Kool Electronics Guy gives it a 9 out of 10. Trust me, it's a really great summer beer. Alright, let's get started with today's project. This one is the 12th in the Arduino Starter Kit. It's called Knock Lock. Arduino says it should take about an hour to build. It's a level 5 out of 5 difficulty, and it builds on projects 1, 2, 3, 4, and 5. So basically, the way this project works is that when you knock on a surface that a piezo is sitting on, it'll trigger a lever on a servo motor to move, which in turn will lock or unlock a box. There's also going to be some colored LEDs that'll indicate the status of the lock. Green will be unlocked and red will be locked. We'll go into more specifics later on this at the end of the project. It really doesn't look like too complicated of a project to me. There's a little bit more code to write on the programming end, but I think it's pretty straightforward. So let's dig in. The components that we're going to use today are one 10K ohm resistor, 3 220 ohm resistors, a 1 meg ohm resistor, a tact switch, 100 microfarad capacitor. We can use one of those, a red LED, a yellow LED, and a green LED, one servo motor, one piezo. We're going to use one 3-pin male header, and of course several jumper wires. Alright, and now as you can see, we got it all wired up. I'm going to walk through the wire up process. We're going to connect power. We connected power and ground to both sides of the breadboard. Added the tact switch to the breadboard and connected one leg to 5 volts. Connected the other side of the switch to ground through a 10K ohm resistor. And then connected this junction to digital pin 2 on the Arduino. Next we added our piezo and attached one leg to power and the other to analog pin 0 on your Arduino. Remember that some piezos indicate polarity. If yours does, then positive goes to power. If there isn't any indication of polarity, then it doesn't matter. Next we placed a 1 meg ohm resistor between the ground and other wire, and then wired up our LEDs. Connect the cathodes, the short legs, to ground by placing a 220 ohm resistor in series with the anodes. connect the yellow LED to Arduino digital pin 3, green to digital pin 4, and red to digital pin 5 through 220 ohm resistor. Connect the male header into the female socket of the servo motor. But as you can see here, we didn't use the header. There's a connector on the end of those wires, the black, the red, and the white from the servo motor. You can see that on the right hand side of your screen. The connector that was on there was absolutely horrible. We had a problem with it in our last project. The male header pins just wouldn't even fit. The holes were so big it just fell right out. We had trouble making connection. So I cut the connector off, stripped the wires down, and tinned them with my solder iron and just plugged them directly into the board. So you can see Arduino says use the 3 pin male header. We didn't. So, you know, maybe yours will come different if you get the starter kit, but the one we had, it just, something wasn't right with that connector. We're going to connect the red wire to power and black to ground on that servo motor. We put the 100 microfarad electrolytic capacitor, that's a tough one to say, right, across power and ground to smooth out the signal. And remember, you know, capacitor is polarized. Make sure you know you connect it properly. You can see the stripe down the side. That would be your negative. We connected the servo's data wire, the white one, to Arduino pin 9. So that pretty much wraps up the wiring. And now we're going to go on to some programming. Alright, like I said earlier, there's a bit more programming in this project, but nothing too crazy, as you can see on your screen. Remember to import the servo library like we did in the MoodQ project. For this first batch of programming that we're doing, the coding we're doing, let's kind of walk through it. We're going to create variables to hold our values from the switch to the piezo. You'll need to set up some constants to use as thresholds for the maximum and minimum knock levels. The lock variable will tell you if the lock is engaged or not. We're going to use a Boolean data type that's true or false, 1 or 0. We're starting with the mechanism unlocked. The last global variable contains the amount of valid knocks received. This is all in our code here, as you can see on your screen. In our setup, we're attaching the servo to pin 9, LEDs as outputs, and the switch pins as inputs. If you see lines 20 through 24 in our code, they'll initialize a serial communication with our computer to monitor the knock volume. If the lock is open or closed, and how many more knocks we'll need. The green LED will illuminate. The servo will move to unlocked, and print the status in our serial monitor. And on our loop, starting in line 25, it'll check if the box is locked or not. If it's locked, it'll read the switch value. This next pick, in lines 28 through 36, those show that if you're pressing the switch, then it's closed. Changing the lock variable to true, indicating the lock is engaged. The green LED goes off and the red turns on. Then be sure to add a delay so the lock has time to move. Lines 37 through 38, check the knock sensor. 39 through 45 count our valid knocks. In this case, it's 3. Lines 45 through 56 are the parameters for an unlocked box. Make sure you close up the loop in the else statements with a pair of curly brackets. Then we'll define a function to check the knock validity. And this final bit of code here, lines 59 through 63 are going to allow us to indicate if the knock is valid. And line 64 lets the main program know what the outcome of the comparison is. 66 through 71 will determine if the lock is too loud or too soft. And make sure to close out the function with one more bracket. So it's kind of a quick walkthrough of the code. You know, and I posted it this time. I usually don't post the code, but you know, I put it there for you guys to check out. And once we finish it up on our end here, then we're going to run the program. Alright, we got the coding complete and the project's running. Make sure the first thing you do is open the serial monitor, as you can see here in your IDE. The green LED should be on and the servo motor in the unlocked position. And we're unlocked there. And you can see the green lights on there. And we're going to try to knock on the piece of wood we got down there and see if this works. We got to push the red button first. There we go. It's locked. The serial monitor says locked. And you can see the yellow light blinking. When you get the right intensity, the yellow light will light up. And you have to hit that intensity 3 times and it'll unlock. You push the button to lock again and see, we hit the right intensity, unlocks. And that's about it for the product. So you know, when you hit the right number of knocks, the LED goes out, the green light takes over, the servo moves 90 degrees, and then it's indicated on the serial monitor. And I'm going to try and pan over here and get the serial monitor in here for you. And you can see how many bad knocks we had on there. And then when we get good knocks, it says so. When we get the 3 knocks, then it unlocks. So that's it for this project. Like I said, the only problem that we encountered was the plug end on that servo motor was horrible, but we overcame that. And the piezo, as you can see, we didn't attach it to the board. We had it plugged right directly into the board. And we were knocking on this piece of wood we set down underneath to give us a good surface to knock on. We couldn't get the project to do anything. So we put, I soldered those 2 jumper wires onto our 2 legs of the piezo and ran those where the piezo would go onto the board. So that the piezo was making contact with the wood. And then when we knocked on the wood, the piezo was feeling that, was in that vibration, and then the project started working, and we haven't had a problem at all. So you might have to try something like that. I don't really think it's going to work if that piezo is right on the breadboard. So we overcame that challenge, and it worked out great. Here's some diagrams to check out. This is a type of box that Arduino says you should create for this project. But I always support creativity, so think outside of the box. You get it? Think outside the box. And design your own. We didn't make a box for this project. We just wired it up and got the servo motor working. Maybe we'll make an enclosure and try that out. But that's it for this project. So please, leave any comments below about the project. I think it was a pretty cool project. It leaves you with so many ideas that you can incorporate into your own projects. So make sure you share your cool ideas with us. Again, leave those comments below. Our next project is number 13 in the Arduino Starter Kit. It's called Touchy Feely Lamp. I didn't name this one. That's all on Arduino. It's kind of a bad title if you ask me, but what do I know? Touchy Feely Lamp. We may have 2 more Arduino Starter Kit projects after this this next one, but we're going to work on a ton of other cool projects after we wrap these up. And that being said, make sure you subscribe to our channel and ring the bell so you don't miss out on any of our cool projects. For the next time, make sure you have some great beer and make some cool electronics. We'll see you next time. Thanks for watching. Have a good one.